Distinguished guests, Your Excellencies, and all those who've come here in the spirit of finding a relationship between the awesome consequences of global climate change and the moral responsibilities that derive from those consequences. I'll just begin briefly since I will be speaking later, but I want to say that for illustration, many of us were astonished to find that a group from the United States called the Heartland Institute was coming here from the United States to oppose the science of climate change. And when we wondered why, we wondered why for the following reasons. Our modern understanding of climate change began in the 1890s with the controversial Swedish Nobel Prize winner chemist Sven Arrhenius, who pointed out that the denser a gas above any object, the more heat must be trapped by that gas, depending on the properties of the individual gas. And of course, the astronomer Carl Sagan and many others pointed out subsequently that the heat of any given planet depends on the composition and the density of its atmosphere. It's not surprising the relationship is almost it's unimaginable that it could be any other way. Now, as this field began to develop, world leaders began to wonder whether it was really well established that human beings were responsible for most of climate change or not. And our own Brent Boleyn, member of the Pontifical Academy of Sciences, became the first head of a body called the Intergovernmental Panel on Climate Change in the late 1990s. And the reason that that panel came into being under the auspices of the United Nations was very simply that they wanted a dependable scientific way of judging whether climate change was real or not, how rapidly it was moving, and what its consequences might be. They didn't ask for and they have not received a social judgment on what to do about it. They immediately enlisted hundreds of the best qualified scientists in the world to deal with all the many aspects of climate change, divided them into panels. Each panel produced a report, and each report was thoroughly reviewed by a wide array of the most distinguished and knowledgeable scientists in the world to determine whether they had hit all the points and whether its conclusions were accurate or not. Then all the reports from all the panels were reviewed by the participant nations, over 100 of them, in the IPCC, and decided, each nation independently decided whether that individual report was ready for release or not, whether they agreed with releasing it, and they agreed that due process had been done to the report. The conclusions have been issued every 3 years, and the most recent panel concluded that with a very high degree of certainty, certainly climate change was occurring, the world was becoming warmer, and that human beings, the activities of human beings, were the major factor in that change. That's very important to establish because groups that want to avoid the consequences that might follow from an understanding that this is the case have decided, as usual, as they did in smoking, as they did in most other scientific findings, have decided that they should attack the science as part of their desire to keep going on with business as usual. Now, I don't know about you, but I cannot imagine a scientific relationship better established than the fact that there is global climate change, that warming is occurring, and that human beings are the major factor in bringing that warming about, that climate change about. No other human idea has been subjected to so much review, so much careful review, so much thought, so much refereed review as this conclusion. And it is purely a mark of the venality of those people who want to go on with business as usual that they would choose to attack the science. Science as usual doesn't say what you need to do about its findings. It simply tells you what its findings are. Science doesn't tell you that you shouldn't jump off the top of this building. Science just tells you that if you do jump off the top of this building, the consequences will probably be bad. It is a measure of the strong desire of people to go on with business as usual that no definitive international action on climate change has been taken yet, despite the fact that there are now 7.3 billion of us growing at 220,000 net per day, that over half the people in the world live in absolute poverty at less than $1.75 per day, or that malnutrition and hunger are so widespread. When you add climate change to all of that, you have an awful mess. In order to change people's point of view and our purpose in helping to organize this meeting, in order to get people to change their point of view, it's not enough to hold up sheets of paper with numbers on them and say this is happening and that is happening and so forth. It's necessary to invoke morality. It's necessary to invoke love. It's necessary to invoke a concern for the human race, which can come in part from the leadership that's exercised by religions, and in this particular instance by the Roman Catholic Church and Pope Francis, which have convened such a distinguished body of religious leaders here to consider that point. Nobody is ever going to change their mind on something that they perceive as being economically costly because you show them the numbers. Only if you get them to open their heart and understand the relationships and the consequences. So that's the spirit in which we're meeting, and shall I call on the people, or will you? I should, okay. Partha Dasgupta, please.
Thank you very much.
Oh, excuse me, we may or may not have a little time for comments and questions at the end of the whole session, but since the program is well behind, that's not certain. But anyway, not after the individual talks.
Thank you very much. I'm an economist by profession, and so I want to look at some aspects of the problem from the economist's specialty, because we, as citizens, look at social problems from various vantage points. In the mornings, we are heads of houses, parents. In the afternoon, we are colleagues. In the evening, we're amongst friends. And we take a slightly different perspective at each such occasion. So as an economist, one wants to ask, and we have an answer, how have we come to this point? Why is it that we have this, face this problem of climate change, but in addition, of course, a wide variety of global and regional and local environmental problems? Biodiversity is one major issue, but the receding forests, drying water holes in villages in Africa, in South Asia, they are linked issues, differing in scale and time, but they have one common feature, which is the fact that when we do anything, when each of us does anything, it has repercussions not only for oneself, but for others as well. Environmental resources are particularly vulnerable. The use of environmental resources is particularly vulnerable to this problem because nature very often moves. The air diffuses. Birds fly. Deer flee. So capturing the consequences, limiting the consequences of your actions to your own self, which you might be able to calculate with reasonable precision, gets eroded. You affect others. So when we emit carbon, of course, it diffuses. It becomes a global problem because you can't contain the carbon that you have emitted to your own sphere, to your own space. That's the source of the problem. There are unaccounted consequences for others of each of our actions, and many of these consequences do not get recorded at the time that you make that decision, and therefore it is missed out. We economists call these phenomena of externalities, the fact that many of these environmental resources, by virtue of this diffusion, are underpriced. They are less costly than they should be. In the case of climate change, in the case of carbon emissions, greenhouse gas emissions, the flip side of it is the fact that we are using the atmosphere, which is a precious commodity, as a sink for our waste. Think of it that way. Just like any other forms of pollution, this is one such pollution at current concentration levels. Of course, if the concentration level were far less, then carbon emission might have, at that time, been even desirable, but not at the current concentration levels of over 400 million parts per million. So that gives us one insight, which is environmental pollution is the flip side, the reverse side of nature conservation. We should think about these problems in a unified way because climate change is only one symptom, granted one of the most important symptoms of the disease that we have inflicted on ourselves. Now, the fact that we underprice this commodity that we are using, namely the sink, the atmosphere as a sink for depositing our pollution in the case of, in the form of carbon, has one very important consequence, which is that we shortchange the future. We may care about our own children, and therefore our grandchildren and great-grandchildren, that's for sure. But our action is having a consequence not only on them, but on the children of our fellow citizens and their grandchildren, and so forth. Our behavior, therefore, is very often interpreted as though we are behaving with myopia, that we do not care about the future. But the source of this problem arises out of these unintended consequences that I just now mentioned. So the data will suggest that we are discounting future costs and benefits at a particular rate, say 5%, but that's not because that's how we view the future, but because our actions have missing elements to it, or have consequences which are missing from our calculations. It has huge implications also in the direction of economic development. I began by asking how have we come to where we are? One reason is that because nature is underpriced, because nature is seen to be far less precious than it is, as she is, the direction of technological change has been consistently rapacious in the use of nature. Reversing that, moving to more friendly technology is certainly possible in many cases, but the fact of the matter is that we are operating with technology which has been created with very, very imperfect understanding of the trade-offs that are involved. What do? One of the things that we'll be discussing today is, of course, changing our moral climate, the kinds of things we ought to do at the individual, household, community level, and so forth. But there's one change that is drastically needed is in the way national accounts are prepared by nations. I say this with feeling because we are all slaves to statistics. If you see a number thrown at you long enough, you start believing it, no matter what the number happens to be. So when we are told that a particular country is doing well because its GDP is rising and the GDP figures are given to you, you start believing those figures and you translate it into a particular evaluative exercise. GDP is a disgraceful index for our purposes for the reason it has some virtues, but the virtues are now swept by the dangers of its use. Remember, GDP is gross domestic product. It means that the depreciation of capital assets is not counted. And here, of course, the depreciation I'm talking about is the damage we cause to the most fundamental form of capital asset that we have, which is Mother Nature. So when nature is damaged, it doesn't get recorded. By the way, the similar problem arises with the Human Development Index of the United Nations as well. Recent work has told us, if you follow the chain of reasoning, the index that we should go, the metric that we should use to judge the progress or regress of economies is an inclusive measure of the economy's wealth. Wealth includes not only human persons, but nature as well as the manufactured commodities that are usually considered when we talk about wealth. So work has been done in trying to redo national accounts by estimating the wealth of nations. We are at a very early stage, but let me give you, by giving you a symptom of what lies in store if we change the way we record our actions through the national accounts. Currently, something like 40 billion tons of carbon are emitted by humanity on an annual basis, or I'm so told. That is unpriced because the atmosphere is a free good to be dumped into. But carbon concentration is bad, as we have just noted. People have been mentioning it. At what price should we give? IPCC reports to which the chairman referred have given estimates, and there are ways of trying to tease out from the consequences to the future in terms of loss of agricultural productivity, rainfall shortages, rising sea levels, and so forth, which are going to take place 30, 40, 50, 60 years down the road. But then remember, we ought to curb for that by reducing the rate at which we discount those losses because of the reasons I've already given. Estimates vary depending on how you should price it. They range from $50 to $100 to $150, $200 per ton. Just for the sake of argument, suppose we were to use as an illustration $100 per ton. Bear in mind it's an underestimate because it hasn't taken into account the fact that the people who are most vulnerable to climate change are the world's poorest. So they should give additional weight to the losses that they suffer. Typically, we feel that is how we should reason when we talk about poverty indexes and so forth. The $100 does not take that into account. Well, suppose you use $100. It means that $4 trillion per year of depreciation is going on in the context of climate change, but it is not recorded in the national or international statistics. Now, that's a heck of a lot of money if you want to talk in terms of monetary terms, but that's a first cut. We'll be talking about morality a lot, but at the end of the day, at some level, when we are at breakfast table looking at our family, we think about our income, what kind of wealth we have, and whether it's depreciating even as we speak. So I wanted to give some reflections on how to give a complementary set of considerations to the ones we'll be considering the rest of today. Thank you very much.
John Schnellenhuber, please.
Okay, thank you very much, Mr. Chairman, Your Eminences, Your Excellencies, ladies and gentlemen. I'm actually waiting for my presentation to be put up, and let's see whether it works. But yes, wonderful. So I am a physicist by training, so I will actually tell you the great story of climate change on this planet in the past and in the future, actually, with a few charts. So the climate has changed over billions of years, actually, and I will show you how it did so over the last 100,000 years. So this is, from ice cores, identified the temperature change in Antarctica. So that is, you see, delta T means up to minus 20 degrees change. And here we go. So this is how the planet was bouncing up and down. What happened there, this is where a major volcano erupted called Toba on Sumatra. That's here. And actually from genetic reconstruction, some experts think that in these years, only a few hundred Homo sapiens were left. So our species was close to extinction because there was a downward jump in temperature in this time. Let's go on. So you see tremendous fluctuations in the last ice age. And finally, a miracle happened. That is what we call the Holocene. This is where paradise emerged for humanity, where people were able to settle down, where agriculture was invented, the Neolithic Revolution. And those few hundreds sort of Homo sapiens back 74,000 years turned into ultimately 7 billion people. It was only possible in the tremendously stable conditions of what we call the Holocene. And I'll tell you a little bit now, why does the climate change at all? And I give you just the longer term factors, of course. This was mentioned by the chairman already. So first of all, the Earth is moving around the sun, sometimes in a circular way, sometimes in a more eccentric way, in a more elliptical way. And the shape is very important. But a second thing is also very important. Our planet is like a spin top, you know, the toy which children use, and its axis can change. That's the inclination or obliquity we call. But the axis as well can precess around the sort of the situation with respect to the fixed stars. And these are the three major mechanisms. And it was discovered by a Serbian geophysicist, Milutin Milankovic, and he wrote down his summary in 1941 in German, actually. I'm German. So Cardinal Turkson, who is a multilingual person, probably can read that book. But there's a second factor. The second factor is what was mentioned already, carbon dioxide in the atmosphere or other greenhouse gases, and they trap the heat, the radiation, and keep the planet much warmer than it would be without them. And this was mentioned before. The famous Nobel Prize-winning chemist Svante Arrhenius from Sweden published this even earlier when Milankovic did that. These are the two most dominant factors that determine the fate of the climate on this planet. And this would go on and on for millions and billions of years. But there's now a new factor, a new kid on the block. We enter what Paul Crutzen famously called the Anthropocene. Let's see if it works. Yes. Now I show you what happened over the last 800,000 years, because we can reconstruct it. A major triumph of science now from the ice cores. You see in the lower part of the panel, you see the temperature changes, and above you see the changing insolation, the changing radiation from the sun. And you see the Earth is dancing to the melody of Milankovic. But there's a second tune coming in, and that is CO2. And you see over many, many years, CO2 was only 280 ppm, parts per million, in the atmosphere, in the Holocene. But you see now a sharp rise. This is human influence. That is the age of man and the Anthropocene. And you see, just last year, we broke through this threshold of 400 ppm. So this is a spike. This is not a natural phenomenon anymore. Now I show you the consequence of that, and I haven't shown this before in any conference. We bring together the two things. It looks very technical, but what have we done? We have calculated when does an ice age start. We call it glacial inception. And it's the combination of two factors, the sunlight, in particular in the northern hemisphere, and it is the concentration of CO2. And what it is saying, when you are below this critical line, this function, it's an exponential function, you will have a glacial inception. That means the big ice sheets will form in the northern hemisphere. If you are above that, you are safe from glaciation. And we have used that now in order to reconstruct the last 10 ice ages, if you like. And it looks a bit complicated, but I guess it's worth to think about it and to contemplate it a little bit. You see a dark blue line, that is the actual CO2 concentration, which we can reconstruct 800,000 years. And you see this black line, which is sort of the critical carbon dioxide you would need in order to avoid glaciation. And you see now, whenever this dark blue line goes below the dark line, when you will have a glacial inception. So we can actually reconstruct the last 10 glaciations. This is the past. And it's a triumph of science when we can explain this now. But here is the future. The blue line would continue without human interference. It's called 0 gigatons of carbon, the blue line, when the next ice age would happen in 50,000 years from now. So we are safe from the next ice age. But look now at the colored curves. This is if you inject into the atmosphere 500 billion tons of carbon, which has happened already, 1,000, 1,500, and I could go on. And you see that even with the 500 gigatons of carbon, we will already avoid the next ice age. Here you can see it much better. The orange line just goes above the critical line for a glacial inception. So there will be no ice age anymore. But actually we will inject much more into the atmosphere. So humankind is changing the glaciation on Earth, which is a major consequence. Now let's go back to the last 100 years and so on, and this is the curve of global mean temperature change. And of course the global mean temperature is rising. You see, there have been spikes downwards, the Pinatubo eruption, you may recall that. There has been a major El Nino event when the Pacific warms in an anomalous way. That was in 1997 and 1998. And you had La Nina phases. But actually, a major El Nino is now developing in the Pacific, which means, and this is a chart from GISS, NASA, one of the many achievements of Jim Hansen. You see that the first quarter of 2015, although the last year was already the warmest on record, is the warmest quarter of months that was ever recorded. But I want you to take home one message also. If you look at 2014 and you look at 2010, you see 2014 was the warmest year on record so far, 2010 the second warmest on record. And people often say, well, how can there be global warming if it's snowing outside? So that's obviously the reason why we don't have global warming. Even in the US Senate, people raise this argument. But what you see is, although 2014 and 2010 were very warm, you have in 2010 a big cold region over Siberia, while in 2014, Siberia, and in particular this year, is anomalously warm, while you have this big freeze over the eastern part of the US. So regional warming does not tell you the picture of global warming. You have to always be aware of that. So skip that and go directly, have two more or less important charts for you. This is to show you the full scale of the challenge. This is the reconstruction again, 20,000 years ago, in the last ice age, the global mean temperature, let me see whether this works. No, it does not work. Okay, let's go back. We had -3 degrees compared to the Holocene. Now, the various lines you see here are the various scenarios which humanity could realize on this planet. If we inject 1,000 gigatons, we would be about 2 degrees above pre-industrial. If we would inject 7,500, and that is, by the way, business as usual, that is the current path we are on, you would have, by the year 2000, 3,000, an increase of global mean temperature of another 6, 7, or 8 degrees. So the full amplitude from coming from the ice age going into the hot age would be 10 degrees global mean temperature change. Compare that to your body temperature. If you would add 10 degrees to your body temperature, you certainly would not survive. Now, let me go on and skip this, because the last 2 points I want to make. Now, if you would increase your body temperature, some of your vital organs would fail before you die. Maybe the kidney will collapse. Finally, the heart will collapse, and when you are dead. And this is what happens in the Earth system. You have so-called vital organs, we call them the tipping elements. It is the great ice sheet. It is the monsoon system, very important for India, for example, for West Africa, even for Latin America. It's El Nino. It's the jet stream. All these vital organs will be transformed by climate change. This is highly nonlinear, highly complex, very hard to understand, but science is making huge progress. And I show you now what will happen to the Greenland ice sheet under this scenario. So see, we can now work out in three-dimensional pictures how it will shrink if global mean temperature is increased by 2 or 3 degrees. And this will mean not only that this ice shield will disappear, it will add 7 meters to global sea level. 7 meters. So my last chart is the following here. Again, you see the reconstruction of the global mean temperature. That's the blue line. 20,000 years ago, we come out of the Ice Age, we go into the Holocene, we enter the Anthropocene. On the right-hand side, what you see, RCP 2.6, that's jargon, IPCC jargon. It means you would actually, in the green case, you would hold the 2 degrees line when you will go above. And the uppermost figure you see, the line, RCP 8.5 on the right-hand side, that's business as usual. And now you would actually tip one by one critical vital organs of the Earth into a new state. And on the left-hand side, you would start with the coral reefs, where will probably even perish under 1.5 degrees warming, 90% of them. And you go on, and the uncertainties are there as well. And you would go on, and finally you would even melt down the Antarctic ice sheet, which is worth 60 to 70 meters sea level rise. Now let me say the following. This is like you are driving a car and you have an array of stop signs ahead of you. All of these tipping elements are stop signs. And you just run over them, one after the other. Huh? You don't stop. You just go on, tuck, 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 like this. And this is precisely what we are doing. So let me conclude. This will completely transform the planet we have inherited from creation. And this is like throwing away God's gift to all of us. Thank you very much.
Thank you, John. Now I'd like to call on Paul Crutzen.
Can we have Crutzen's slide? Paul Crutzen's presentation?
John, that was terrific.
Thank you.
Absolutely first rate. It's even better than last year. I think this was more around it.
Thank you so much. Now I have to show the picture. So and
That is possible to do it in 12 months, isn't it?
and it's
In my talk,
it's impossible. But
I start with, sorry. The first slide,
You want to move closer to the microphone? Oh, sorry. Yep.
okay, that's what I, the situation in the atmosphere at this time compared to that for earlier times. What is shown here is the growth in the composition of the atmosphere. Various gases are here shown. And what you see is that we have, what you see is we have seen an enormous increase in the concentration of various trace gases and other climatic. These are not percentages, these are real data. Without any percentages, that's the real situation in the atmosphere, not expressed in percentage, but in the actual amount in the atmosphere. You see that the increase has been of the order of, say, 9 or 17 or whatever concentration of species you measure. So this is something I would like to present to the skeptics who say that human impact has been no consideration. If you look at the actual concentrations of these properties in the atmosphere, you come up with enormously surprising results. Next. So if you consider the let's go to the lower part of this slide. What you see is that there has been an increase in the concentration of fish. Fish catch increased 40 times. It's of course very nice to have a lot of fish, but that is just too much. This change in SO2, sulfur dioxide, has been substantial, and we all know that carbon dioxide, sulfur oxide, SO2, in the atmosphere, and its oxidation leads to acidity in the atmosphere, on the Earth, and again, big changes. Release of nitric oxide should be considered. It has been substantial, and nitrogen oxides, NO, is an important chemical compound of the atmosphere because of its oxidation, which leads to SO2, and from there on to nitric acid, adding to the acidity of the atmosphere. Next. We have been very wasteful with the use of water in the atmosphere and on the Earth's surface, and that is expressed in this cartoon. Again, what this cartoon tells you is that we are wasting water, a valuable resource, for our pleasures, to cook coffee or any other let's go to the next slide. One of the consequences of human activities when we consider the surface of the Earth is depicted in this figure. well, that's bad. And one of the, we see the major importance of, we have shown it, of changes in the atmosphere because of human activities. And let's have a look at some of these changes. We have 20 to 30% of nitrogen fertilizer is taken up by plants. About 30% of the fertilizer is actually going to the plants. So altogether, we see that due to human activities, of the order of 50% of the input of fertilizer is just wasted. This is due to use of fertilizer, nitrogen, and other species. One thing I would like to emphasize here is that due to the use of, in order to produce the fertilizer, nitrogen and other compounds, 50% is wasted, 50% is used by the plants. Now, an important compound of the fertilizer is phosphorus, and phosphorus needs to be supplied to the plants. And the big question is whether there will be enough phosphor available to grow plants. Let's go to the next. What I would like to add to what I've said before is that what will be the situation in the future with regard to the availability of phosphorus, and we simply don't know very well how much phosphorus will be available to grow plants in the future. What makes the thing sort of loaded is that phosphorus is produced only in some places on Earth, and they are mentioned here. Morocco is the leading producer of phosphorus. Then we come China, Jordan, and South Africa. So if we have a very restricted availability of phosphorus, and when you look at this, you should get worried, because will there be in the future phosphorus available for other species, for other lands, regions? Will this be a situation which in the future might get very dangerous, because some people will have plenty of of phosphorus. Most of the world has just very little phosphorus. So here I would like to end. Thank you for your attention.
Next, I'd like to call on Martin Rees.
Thank you, Chairman. The backdrop to today's discussion is the imperative to transform our relationship to nature. Traditionally, we felt dwarfed by its scale and sublimity, humbled in the face of its forces, and we still are. But there's now an extra dimension. We've entered the Anthropocene, and we have a symbiotic and not passive relationship with nature. There are more of us, 9 billion by 2050, and we're each more demanding of energy and resources. We're collectively ravaging the biosphere and risk changing the climate in unprecedented ways, as we've heard. The phrase sustainable development was, of course, introduced by the Brundtland Commission in 1987, defined as, I quote, development that meets the need of the present, especially the poor, without compromising the ability of future generations to meet their own needs. And it can't be said too often that it's those in poor nations, the disadvantaged 3 billion who are still denied the health care and energy that's been the birthright of Europeans, who can cope least well with climate change. And they're the ones who should be at the forefront of our concerns. But of course, they're not. For politicians, the immediate trumps the long term, the national trumps the global. Activists and experts by themselves can't generate political will. Only if their voice is amplified by a wide public and by the media will this cause rise high enough on the political agenda. And this is where the faith dimension comes in. The Catholic Church is the most powerful institution that transcends normal political constraints. There's no gainsaying its global reach, nor its durability and long-term vision, nor its focus on the world's poor, especially under Pope Francis. And that's why this agenda is of huge importance and why I feel privileged to be here today. As regards to science, it's agreed by everyone that CO2 is rising for anthropogenic reasons, and this is causing warming. But there are, of course, some uncertainties about the rate, about the so-called climate sensitivity when you take account of water vapor, clouds, and so forth. But there would nonetheless be broad consensus on two things. First, climate change won't be globally catastrophic in the next 30 years, though there's already a need in the developing world to adapt to it. But second, continuing burning of fossil fuels could, by the end of the century, trigger an irreversible climatic catastrophe, whose consequences would last for thousands of years. There's a consensus on those two things. But we all know that despite that broad consensus, there is a diverse set of views on risk management. Risk assessment is agreed on, risk management is not. And this stems from differences in economic assumptions and views on intergenerational justice. Let me expand on this. Some economists, for instance, Born Lomborg's Copenhagen Consensus, they downplay the priority of tackling climate change compared to other ways of helping the world's poor. But that's because they apply a standard discount rate and in effect write off what happens beyond 2050. But if you care about those who live in the 22nd century, you would deem it worth making an investment now to protect future generations against worst-case scenarios. In effect, you would apply a very low long-term discount rate. So even those who agree that there's a risk of catastrophe in 100 years will differ in the urgency with which they advocate action today. Their assessment will depend on the discount rate, expectations of future growth optimism about technological fixes, but above all, on an ethical issue. In optimizing people's life chances, should we, as it were, discriminate on grounds of date of birth? And the message of the Church, of course, is that we should not. We should care about the far future generations. The second ethical issue concerns the non-human environment. We know that humans are threatening biodiversity, and this threat is aggravated by climate change. Some talk of an ecological shock, a sixth extinction comparable to the 5 inferred from the fossil record. We're destroying the book of life before we've read it. Now, we're clearly harmed if fish stocks dwindle. There are plants in the rainforest whose genes may be useful to us. But for some, this is too anthropocentric a view. For them, biodiversity has intrinsic value over and above its benefit to humans. It's part of nature. And to quote the great ecologist E.O. Wilson, he says that if our despoilation of nature causes mass extinctions, it's the sin that future generations will least forgive us for. But finally, what is really likely to happen on the political front with Paris and following meetings? We surely hope that public pressure, bolstered by faith groups, will energize political efforts to think long-term and globally and decarbonize energy generation. And I think there are 3 things that are plausible medium-term goals. First, ensure clean, safe, sustainable energy for the bottom 3 billion. That's the imperative. Second, for us in the developed world to reduce our footprint, be more energy efficient, etc. That'll actually save us money. But third, we surely need to speed up the transition to a low-carbon economy. And this may need an enhancement in research and development so that we can develop more quickly the kinds of clean energy that can take over. Indeed, why shouldn't that kind of R&D be on the scale of medical research? It's far lower than that. And indeed, the goal of supplying sustainable clean energy for the developing and developed world is surely something that would infuse young people as an exciting goal for their lives. But if the current torpor persists, then the best projections indicate that atmospheric CO2 is going to rise at an accelerating rate throughout the next 20 years. We'll punch through the 450 parts per million ceiling. And this, of course, risks putting us on a rapid trajectory into dangerous territory. Now, if indeed nothing happens in the next 20 years, and that becomes the perception, then there may be pressure for all kinds of panic measures, which would have to evolve some plan B, combating the effects of the warming by what's called geoengineering. Now, this would be really, really bad news. It's feasible to throw enough material into the atmosphere to counteract global warming. Volcanoes do this naturally, we could do it. But the political problems of such geoengineering will be overwhelming. Different countries would want to turn down the thermostat differently. And there'd be unintended consequences too. Moreover, the warming would return with a vengeance if the countermeasures were ever discontinued, and other consequences of rising CO2, in particular the effect of ocean acidification, would be unchecked. So there is an issue about whether we should even think about geoengineering and who should make the decisions. Remember that those most at risk are in countries with least power and the lowest capacity to adapt. We're on spaceship Earth. It's hurtling through the void. Its passengers are anxious and fractious. Their life support system is vulnerable to disruption and breakdown. But there's too little planning, too little horizon scanning. And without a broader perspective, without realizing that we're all on this crowded world together, governments won't properly prioritize projects which are long-term in a political perspective, even if a mere instant in the history of our planet. It would surely be shameful if our inheritance to future generations was a depleted and hazardous world. and that's why sustainability needs to rise higher on the agenda, and that's why this meeting seems to me such a bright portent. Thank you very much.
Thank you. Dr. Ramanathan?
Thank you. I work deep in the trenches of climate change science, and I know our predictions of the future are uncertain. So for example, when we say 2-degree warming by middle of the century, it could be as small as 1 degree, or it could be as large as 4 degrees. So given this uncertainty, what makes a scientist like me in the trench come out of it and appeal to a distinguished group like this, and particularly the religious leaders, to help us solve the problem? So I'm going to take you through a personal journey of 40 years in 5 slides. We all heard about Svante Arrhenius' I'd say path-breaking work, first quantitative estimate in 1896 of the link between increase in the carbon dioxide and global warming. So for 80 years, we thought CO2 was the only man-made greenhouse gas we had to worry about. And then in 75, I stumbled on this finding that halocarbons are really super greenhouse gases. Chlorofluorocarbons was one form of halocarbon used as refrigerant. And we found adding 1 molecule of this CFC would have the same effect in warming the planet as 10,000 molecules of carbon dioxide. Fortunately, because of the work of Crutzen, Molina, and Rowland, CFCs were banned not because of the climate effects, but its effect on the ozone layer. Since the climate effect of the halocarbon was not recognized, we replaced the CFCs with HFCs, which are still super greenhouse gases. And that's why I think we shouldn't forget society has already succeeded in mitigating climate change. But like I said in my introduction last week, the Montreal Protocol has been made to amend it to ban HFCs for the first time, recognizing the climate effects of halocarbons. So the Montreal Protocol alone, if they ban HFCs, would have saved us almost 10% of the global warming. So let me turn my attention to the real gorilla on the table, the Arrhenius theory on CO2 and linked with global warming. So as we all know, every theory has to be judged by the prediction it makes. So we took, in the study published 35 years ago, projections of future climate by pioneering modeling studies like Jim Hansen and Schellenhuber and others. What we found, after allowing for the natural climate variability, which John showed clearly, that the CO2 warming should be detectable by year 2000. And as the observed records show, that's when a panel of 1,000 scientists under IPCC said we have detected a discernible warming. So at least in this case, the theory withstood a critical test. I then went after several other model predictions about the future using a battery of observations, satellites, and then this experiment which Paul Crutzen and I did in the Indian Ocean with ships and aircraft. And last 10 years, I've been using unmanned aircraft to spy on air pollution and its link to climate change. Let me show you 2 examples of what we found. We went after every aspect of this model change. The first was just published. It took us 25 years with our data to come to this result. We all know the sea ice is retreating. I'm showing on the top the September 1979 when our record started. And then we looked at the trend, and the bottom one shows the sea ice extent in 2012. The ice, because it's so white, it reflects 50% of the sunlight. But once you blow the ice out, expose the darker ocean absorbs 80%. So overnight, you go from 50% to 80% absorption. And we found, actually documented, the heat went into the Arctic Ocean. It really confirmed model predictions which were made, but the actual observed increase of the heating of the Arctic was a factor of 2 larger, not smaller. And the next one, everyone knows, clouds is a major source of uncertainty. We simply don't know the warmer climate, is that going to be more cloudy or less cloudy? These extratropical storm track clouds, which we see over the Atlantic and Pacific, they reflect so much sunlight, they help the planet's temperature under control. So both hemispheres, we have like 2 umbrellas, one over the Antarctic, one over the Arctic, shielding the planet from intense sunlight. What we found in the last 25 years as the planet was warming, these extratropical storm track clouds were retreating polewards, which means letting more sunlight, again an amplification. This work, by the way, was done by a colleague with NASA. So I can just show you many, many examples. Sea level rise. Most of the things we see changing are larger than what was predicted by models. So I'm more leaning towards, when the models say 2 degrees, is it going to be 4 or 1? I'm leaning on the 4 side based on the observations we have collected. So I want to conclude with who are the vulnerable population. Since last 5 years, I'm working on this idea. There are, in fact, 2 worlds in this planet, codependent. The first one's inhabited at the top 1 billion. We seem to have unlimited access to fossil fuels. Contrast with the bottom 3 billion, that cook stove, I was living in a hut behind that woman's house. She's actually cooking my breakfast. And it comes as a huge expense, like I said, 4 million deaths every year. And the pollutants from the cook smoke, the black carbon settles on the glaciers and contributes to melting. There's just enormous cost. And I'm living in California. We're experiencing severe drought last 5 years. I must tell you, it has brought a super state within the superpower like US to our knees. Our governor was begging us to not waste water. Imagine a drought of 3-4 years, what it would happen to this population. It would basically make them homeless and penniless. So if you're still looking for certainty, I want to conclude with this famous report. I've fallen in love with this, written by 16 generals and admirals. So they conclude, some in the political realm continue to debate the cause of a warming planet and demand more data. Yet, this military advisor board member, General Gordon Sullivan, has noted, speaking as a soldier, we never have 100% certainty. If you wait until you have 100% certainty, something bad is going to happen on the battlefield. That battlefield is the 3 billion to go under first. Thank you.
Dr. Yuan Li.
Ladies and gentlemen, it is my great honor to be able to join you here. Like most of you, I've been to more meetings than I can remember, conferences and summits on the sustainable future of mankind. But to be honest, after so many years and so many gatherings, there was never enough progress to say, okay, we are now heading towards a sustainable future. This year seems different, and this summit seems different. This year, we will get a set of sustainable development goals and perhaps a climate agreement to give us hope. And this summit is an incredibly important part of the journey. While most discussions focus on how technology or the market can save us, this summit is about something equally important, but really talked about the morals, values, and attitudes. the statement argues that we need a transformational change in attitude. I couldn't agree more. My remarks will focus on 3 changes of attitude: political, social, and scientific. First, the political. Every year, countries spend trillions to defend against other countries, but we all know that the biggest threat today and in coming years will come not from across the border. It is climate change, a global threat to all mankind. No individual or country can face it alone. If we do not come together, climate change will be on top of us in the next 10, 20 years, and it will destroy us. We must go beyond individual countries, beyond Italy, Brazil, and Japan, beyond even the European Union and the United Nations. We might need something like the United States of the planet of Earth. I made this point a few months ago in a talk, and the French Environment Minister, Madame Royale, was in the audience when she summarized the meeting toward the end. She said that every human should have 2 citizenship, one for their country and another for planet Earth. I could not agree more. The second citizenship should become more and more important. This is the political change of attitude we truly need. And now the social, which is our attitude towards development. In the last hundreds of years, because of exploding population and consumption, humans have overloaded the earth. But whenever I mention this, that we are overdeveloped, people in Africa, in South Asia would say, Professor Lee, don't say that. We are miserable. We have to develop. The question is, what do we mean by development? When one person owns 10 homes and 10 sports cars, is that development? China consumed more cement in the last 3 years than the United States did in all of 20th century. Is that really a good way of development? In Taiwan, where I came from, people said our GDP is only 1/3 of the US, so we need to grow. Is that a sustainable way to develop? No. Places like Taiwan, the US, and other rich countries have actually overdeveloped. We have to recognize we are the ones who are overloading the earth. The emerging country must not follow this path. We must transform the world's attitude toward what true development or true sustainable development really is. And finally, we need a change of attitude on science and technology. When we talk about decarbonizing human societies, we really mean giving up fossil fuels and going back to sunshine. But there are still some problems. A friend of mine in California tells me that she can live on sunshine with solar panels on her roof. Don't they satisfy all her electricity needs? The excess electricity can also charge a Nissan Leaf, an electric car. So she is close to carbon neutral. She challenged me, Professor Lee, can you do it? Can you do it in Taiwan? I said, no, I cannot do this in Taiwan because Taiwan has population density 20 times higher than California. There's not enough sunshine to live on. And Taiwan is hardly alone on this. So we need to learn how to store renewable energy, especially sunshine, convert it maybe to electricity, and transform it so it can transport it over national borders. This might be the only way for many countries to go back to sunshine. We must accelerate the development of such science and technologies. In summary, I see at least 3 transformational changes in attitude needed for sustainability. Politically, can humanity unite as a global community against climate change rather than against each other? Socially, can we recognize that we have overloaded, overdeveloped, and aspire to a different path? Scientifically, can we develop the science and technology necessary to allow even the sunshine-poor places to live on the sun? These are moral questions. Future generations will judge us not by whether we did well or badly, but by whether we did the right thing. The people gathered in this room today have truly enormous power to shift attitudes around the world. This is the year to do it. Thank you very much.
Thank you. It would be impossible for me to summarize the remarks that have been made in such a rich assortment by our previous speakers, but I will make a few comments. We should all have been completely convinced, if we were not before, that global warming is happening, that it's happening at a very rapid rate, that that rate is unknown, but that, as John Schnellenhuber has pointed out so well, the surprises may as well be, or may even be more likely to be, negative than positive in the future. 10,000 years ago, our species appeared on Earth, or our group of organisms appeared on Earth about 2.3 million years ago, as we now understand it. 10,000 years ago, which is a very short time in human generations, about 40 generations perhaps, the human population of the entire Earth was about 1 million people. 10,000 years ago, about 100,000 in Europe. At that time, before agriculture was used widely to support us, we lived as independent groups of people passing through the forests and plains, attacking one another, gathering as much to ourselves as we could, getting as much as we could whenever we could. And we've apparently tried to use that morality in building a modern world. We are still standing against one another rather than together, and it's obvious, I think, as Yuan Li has pointed out a minute ago, that the United Nations, or a group like the United Nations, will really be necessary to take a much stronger stance on environmental matters and on matters of getting along together, even though at the end of World War II, it was founded largely on matters of war and peace. Questions of war and peace are going to be determined to a very large extent in the future by questions of the environment. Our population has grown over just 10,000 years to 7.3 billion people living in the world at the present time. 220,000 extra people net are added every day. 220,000 people have to be fed more each day than were fed the day before. Of the 7.3 billion of us, 800 million are malnourished to the point where their minds and bodies did not develop properly while they were growing up, and 100 million people are on the verge of starvation at any point in time. Then when people say, well, nobody will do anything about this until there's a real catastrophe, one wonders what kind of a dark soul could enable somebody to look at 800 million malnourished people, 3 billion people who are malnourished in terms of at least one element, and 100,000 people at the verge of starvation, with hundreds of millions of people having starved to death during the 20th century, and say, let's wait for the catastrophe and then we'll get busy. With that kind of pressure on the environment, we are producing greenhouse gases at an enormous rate, and those greenhouse gases are changing the conditions in which we live. Of particular importance, as Martin Rees and others have stressed, is the fact that we depend entirely on the living world for our life here on Earth, both in terms of individual organisms from which we get all our food one way or the other, in terms of the properties of the atmosphere, even though we're changing that rapidly, in terms of the functioning of the soil, in terms of the retention of water in certain patterns on the surface of the earth, we depend on the living world. Aside from bacteria, which no one can count accurately, we have about an estimated 12 million species of organisms in the world. We have named about 2 million of them, about 1 in 6. So about 5/6, other than bacteria, do not even have a name. And then consider that over the last 10,000 years, we've expanded agriculture, crop agriculture, and grazing, mostly unsustainable, mostly on wild grasslands, to 1/3 of the world's land surface to poorly feed 7.3 billion people, very inadequately, very unevenly, very contentiously, and in a very divided way. Hundreds of thousands of species obviously went extinct while we were expanding agriculture over 1/3 of the world's land surface, and they are becoming extinct now at a rate which has not been equaled since the end of the Cretaceous period, when about 2/3 of all organisms on Earth disappeared rapidly at the end of the age of the dinosaurs and the beginning of the age of the mammals. We're now in the middle of a great age of extinction, and yet this one we're driving ourselves, and we don't really care if you measure whether we care or not by our actions. Global warming, which we say, well, maybe this speed, maybe that speed, maybe we need to act now, maybe we don't act now. Not only if all the ice melts will drive up the level of the sea by 80 meters, which is going to be very inconvenient for most countries, not this year, not next year, but at some unavoidable point in the future, we have to come together to get a hold of this. As President Werner Arber of the Pontifical Academy of Sciences mentioned at our last meeting, the question that we face now is really not a question of whether our children or grandchildren will be well off. The question that we face now, and I think you'll agree with me if you consider all the factors involved, is really whether the kind of things that we enjoy as civilization in the world will still exist 50 or 100 years from now. With the kinds of pressure we're putting on, and Global Footprint Network estimates that we're using about 156% of global sustainability on an ongoing basis, which far exceeds the carrying capacity of the Earth, but which at the same time leaves 800 million people malnourished and 100 million on the verge of starvation. That's not getting any better. The Bible tells us that Adam was commanded to serve and preserve the earth, but we're clearly not doing it. Only a deep and wide moral revolution could possibly make us overcome our Stone Age proclivity for greed and to choose new directions before we get much deeper in the hole. We're already in the hole. The competition between nations, the competition between rich and poor, the alienation between men, women, and children being absolutely excluded from society in many parts of the earth, the matter of human trafficking, all of those are being carried out against the background of a delusionary, ever-growing economy that would allow us to be all right no matter what happens. But on a finite earth, that kind of a delusionary economy is not good enough for us, no matter how much we choose to ignore the global situation for the sake of short-term local gain and for maintaining the pretense of business as usual. We hope that the religious leaders and the moral figures gathered here together will help us to learn to love and care for one another in ways that we have not even begun to understand. I hope this meeting will make a substantial contribution to nurturing our progress in that direction. Thank you.